We are going to do maths centroid chapter 5 for N6 mathematics. So we also cover some of the subjects here and some are not written here. So if you want more, you can just visit on the blog, and also you can also visit on the YouTube channel, or you can subscribe for more videos like this. So when you subscribe, you'll go to the playlist and then go to check the N6 mathematics, and then you'll get the list of other problems that are done there, exercises. So there are other more subjects which you can, which also you can find it here for NET, for NCV, for technical school, and QF, and TVET, high school, primary school, and more. So these are the exercises that you will find on the next coming videos. This is centroid, so I'm dealing with centroid here. So let's look at this exercise. So they say sketch. As you can see, this is a parabola. Parabola is either going up or down. So this is the nature of one of the parabola. So this is a graph that looks up. So it's important to know the nature of the graph, because it makes it simpler for to write in an exam, because they don't give much marks for calculating or doing the x-intercept, the y-intercept. Only give you marks for the graph. So if you draw the graph right, you'll get your marks. So this is y. X square. So this tells us that it doesn't go to, your y-axis does not go to the negative for this graph, this square. So any value you put here always come positive, so it goes like this and this. So on your y-axis is a positive values, so you'll get positive values, unlike in the straight line. The straight line one, it's like this. Let me, the straight line one is like this and does not have a square, so a square help us to get the positive one. So the straight line one goes like straight, so it tells us that also the negative is included here, and the negative are not included for the y-axis. The x-axis, yes, because the y-axis depend on the x-axis value. So if the x-axis become negative, the graph goes up. Also on the positive it goes up, but on the straight line it doesn't. The straight line goes straight to this side. So this is your straight dx. This is how you draw your graph. You can use the table, and the table is more safer if you can draw it using the table. So you just draw your table, you write your x-axis 1 2 3, or -3 1, -2 -1 0, and 2 to 3, and then you draw your equation. You can use a table like this to draw the yeah, that you can do it like this. So number B, this is a graph, this is a stripped. These are the boundaries that they tell you about. This one, the x-axis, y is the graph, which is this one. Then the line line x goes to 4 is the line, and the x-axis. So this is the axis. So we are looking at this area. This area is the one that we are looking at because we are told about the boundaries. So you draw the graph and then you check the boundaries where they want it to be. So let's do number B. Determine the magnitude of the area bounded by the. So an area is, because your strip is already in the dx, your limit is 0 to 4. And then you substitute the x square here because it's the y. So before you substitute, you have to deal with the, you have to change everything be in terms of x before you integrate. So now you can see it's x now. So integrating this one, you will have x cubed over 3 0 and 4. So the 0 one, it will be 0. If you substitute 0 everything, it will be 0. Then 4 cube is 64. 64 divided by 3, let's use a calculator. And 1,333. So because it's a unit square, because an area is a unit square, it's measured in unit square. So number C, determine the area moment. So for the area moment bounded by the area about the x-axis, about the x-axis, like taking the moment about the x-axis, which is the, we are looking for y bar. So we have, so we'll explain this how to do the area moment equation, how it's been derived on other videos. So just keep on watching the videos for area moment, so it will help you to understand better. This is y square, so you substitute the value of y square here, and then the boundaries or the limits is 0 to 4. Then integrating, you will have, not integrating, simplifying this one, you'll have then you integrate, the half must be, the limit is 0 and 4. Then we'll substitute the 4 there. 4 raised to 5, what we get? 4 raised to 5. Already substituted 4 raised to 5, and then when you substitute 0, it becomes 0 this side. Let's see, divided by what? Let's say 2 times this 10. So you just have 102.4 unit cube. So this is how you calculate the area moment. And then the last question is determine the distance of the centroid from the x-axis. If they say from the x-axis, it's a y bar. If they say from the y-axis, it's x bar. So vice versa, and take it like this. So we are looking for y bar. The area moment about the x-axis is also a y bar. So because we have already got a, the value of a, which is the area, that is the area, 21.33. Comma 3 recurring. So divide by 10, divide by 21, comma it's 4.8 unit. So this is how you calculate the centroid. The centroid is the center of a certain object, or of this graph. As you can see, we'll use this method. You can also, this one can be up by one strength on engineering science as well, but the way they are doing is using the integral sign. So you normally will do it in strength and in engineering science, but in a different way, not in the integral way, and in different kind of structure, not in the graphs. So thank you for watching, and see you in the next